Good morning. Today we are going to see processor unit with control variables, which is coming under computer organization and architecture. As we all know, processor unit consists of arithmetic logic unit and control unit. The arithmetic logic unit, that is ALU, which will perform all arithmetic and logic operations. And the control unit, which will control overall functions of processor unit. The selection variables in a processor unit control the micro operations executed within the processor during the given clock pulse. The selection variables control the buses, the ALU, the shifters, and the destination registers. Let us see the block diagram of a processor unit, which consists of register file R1 to R7, two multiplexers, which will select the input to the ALU. The ALU will perform the arithmetic and logic operations, and the result is given to the shifter. The shifter will either left shift, right shift, or no shift. After the operation, it will give the output to the destination register or to the external destination. And there is another register, status register, which consists of 4 bits C, S, Z, and V. That is carry, sign, 0, and overflow. The carry bit consists of, if the output contains any carry, then the C bit or the carry bit is set to 1. Otherwise, it is set to 0. If the output is having sign, then the S bit is set to 1. Otherwise, it is set to 0. If the output is 0, then the Z bit is set to 1. Otherwise, it is set to 0. And if there is an overflow, then V bit is set to 1. Otherwise, it is set to 0. That's the status register. The processor unit consists of 7 registers, R1 through R7, and a status register. The output of the 7 registers go through 2 multiplexers to select the input to the ALU. Input data from an external source are also selected by the same multiplexer. The output of the ALU goes through a shifter and then to a set of external output terminals. The output from the shifter can be transferred to any one of the registers or to an external destination. There are 16 selection variables in the unit, and the function is to specified by a control word. So these 16 control word or control bits or selection variable is used to perform a micro operation. So this 16-bit control word, when applied to the selection variables in the processor, specifies a given micro operation. So this is a control word. The control word consists of 16-bit and which is divided into 6 fields: A, B, D, F, C, and H. So each field is given a letter naming, and except C, all other fields consist of 3 bits. The B field is the 3 bits of A. Select source register for the input to left side of the ALU. The B field is the same, but it selects the source information for the right input of the ALU. The D field selects a destination register. The F field, together with the bit in C select a function to the ALU. The H field selects the type of shift in the shifter unit. So consider the block diagram we have discussed earlier. Here, A field. The A field which will select the input to the left side of ALU. The B field selects the input to the right side of the ALU. And the ALU will perform operation according to F and C, that is F field and C, and the output is given to the shifter. The shift operations are decided by H selection variable. So if H is 0, 0, 0, it will indicate no shift, or 0, 0, 1 indicate right shift, 0, 1, 0 indicate left shift. So according to the selection variable, the shift operation is performed and the output is given to the external destination or to the destination registers. The destination register is selected by the D field, and according to D field, one register is selected, and to that register the output is stored. The functions of all selection variables are specified in the table. So consider 001, 001, the binary code 001. When applied to A field, the R1 register is selected, and when applied to B field, same, the R1 is selected, and when applied to D field, the same R1 is selected, and 001 is when applied to F field, when Cin is 0, then A plus B, that is addition operation, is performed. When 001 applied to F field with Cin is 1, then A plus B plus 1 is performed. Then when 001 is applied to H field, shift right is performed. So according to the binary code, particular field is selected and particular operation or particular function is performed. So the 3-bit binary code listed in the table specifies the code for each of the 5 fields A, B, D, input data, F, and H. The register selected by A, B, and D is the one whose decimal number is equivalent to the binary number in the code. That is, if binary code is 001, then R1 register is selected. If the binary code is 011, R3 register is selected. When the A or B field is 000, the corresponding multiplexer select the input data that is from the external source. When D equal to 000, no destination register is selected. The 3-bit in the F field together with the input carry, that is Cin, provides the 12 operations of the ALU. So for example, if R1 gives R1 minus R2, from this micro operation we can say that R1 is the one input to the ALU, R2 is another input to the ALU, and we are performing subtraction operation, and the result is stored in R1. So as it is a subtraction operation, there is no shift, so no shift is selected from the shifter. So we can easily derive the control word for this micro operation. So for A field, the R1 is the first input. So A field, we are giving 001, and for B field the second input is R2, so we are giving 010, and the destination is D, that is 001, that is R1 001. So the operation we are performing here is the subtraction. So the F field is 010 and Cin is 1, and there is no shift in the shifter, so H field is 000. So the control word for this operation is 001, 010, 001, 010, 100. So we can easily derive any control word for the micro operations. So a control word of 16-bit is needed to specify a micro operation for the processor unit. The most efficient way to generate control word with so many bits is to store them in a memory unit, which functions as a control memory where all control words are stored. The sequence of control words is then read from the control memory one word at a time to initiate the desired sequence of micro operation. So this type of control organization is called microprogramming. So if we are having so many control words, so we can store it in a control memory, and we can sequentially read one word at a time and execute it, and we can perform the micro operation. So this type of control organization is called micro programming. So that's all about processor unit. Thank you.